the integral of 1 over x squared times the square root of x squared plus 4 dx. We see that there is the x squared plus 4. So let's go ahead and use trigonometry substitution. It's not the first form, but it is the second form. We can see that a squared is 4, so a will be 2. And we only want the positive integer. So x equals a times tangent, and a is 2, so we have 2 times tan. And we also need to find the derivative. So dx over d theta is equal to 2 times secant squared. Then we multiply both sides with d theta. We will have the integral of 1 over x squared. So x is 2 tan, and x squared would be 4 tan to the power of 2. So 4 tan to the power of 2 times the square root of x squared again. So x squared is 4 tan to the power of 2 plus 4 times dx. So times 2 secant squared d theta. I'm going to put x equals 2 times tan up here. Now let's solve the denominator. Let's simplify it first. We have 4 tan squared times the square root. 4 tan squared plus 4. Let's factor out the 4. So we have 4 times tan squared plus 1. And we know that tan squared plus 1 is secant squared. So let's go ahead and replace it. So what is the square root of 4 times secant squared? It's going to be 2 times secant. So this will be our new denominator. So the 2 here will cancel out with this 2. We have secant and secant squared, so they will also cancel out. We can move the 4 outside of the integral, so we have 1 over 4, the integral of 1 over tan to the power of 2. So 1 over tan to the power of 2, and this is basically the same as cosine squared over sine squared. Then we multiply by secant, and secant is basically 1 over cosine d theta. And as you can see, we have a cosine squared and a cosine, so they have to cancel out. We can also get rid of this because this is basically times 1. And we have to do u substitution. So let u equal to sine of theta. So du over d theta is going to be cosine. So du is cosine theta, d theta, and d theta is 1 over cosine du. This is equal to 1 over 4 times the integral of cosine over sine squared, and sine is u. So we have u squared times d theta, and d theta is 1 over cosine du. And the cosines will cancel out. So we have 1 over 4 times the integral of 1 over u squared. And let's go ahead and write it as u to the power of negative 2. So u to the power of negative 2, then we have du. This is equal to 1 over 4 times the antiderivative of u to the power of negative 2. And that's going to be u to the power of negative 1 over negative 1 plus c. So we have negative 1 over 4 times 1 over u plus c. So u is basically sine. So we have negative 1 over 4 times sine plus c. This is where our equation comes in. So x equals 2 times tan. So tan is x over 2. We have a right triangle, and here is our opposite side. Then using SOHCAHTOA, tan is opposite over adjacent. So the opposite side is x. The adjacent side is 2. And we want to find the hypotenuse. So c squared is equal to x squared plus 2 squared. So c is the square root of x squared plus 4. What is sine going to be? Well, sine is the opposite over hypotenuse, and opposite is x. Hypotenuse is the square root of x squared plus 4. Our integral will be equal to negative 1 over 4 times 1 over sine plus c. So 1 over sine would be the square root of x squared plus 4 over x. Using this, we have negative 1 over 4 times the square root of x squared plus 4 over x plus c. And let's write this as negative the square root of x squared plus 4 over 4x plus c. And this is our answer.